Hi there. Let's get started with our first lecture. Today we're going to talk about where our water comes from. This is a course about irrigation. And before we get into all the details of the components, the parts, how to put them together, and how to make it work, we're going to spend a little bit of time talking about water in San Diego and how it works and where it comes from, and why we need to have irrigation in the first place. Now, this lecture I was going to give in 2 weeks, but I wanted to do this introduction. And then in 2 weeks' time, we're going to start the QUEL, Qualified Water Efficient Landscaper. You're going to receive this manual in the mail, but we're going to go ahead and start with the first chapter because it's basically the same as the introduction that I was going to give. And when you do get this manual, I'll be able to help you refer to section 1, where our water comes from. So in this class, we will be bouncing between the QUEL curriculum, because that's a third-party certification that you can get, and it will help you in your career. And we're going to use that curriculum as a foundation, and then we'll take different subjects and we will spend a little bit more time in depth with each one as appropriate to this course. So for the purpose of this class, we're doing section 1, chapter 1, where our water comes from. And we're just going to do the QUEL curriculum standard. These are PowerPoints that are given all over San Diego County. I will be giving them to you, and I'll throw in some of my own commentary as we get there. So let's get right to it. I'll share my screen here. Okay, so this section is where our water comes from. And this is an important subject when we talk about irrigation for a number of reasons. First of all, it's important to think about where we are in the world. And we're in one of the few unique places in the world where it is dry in the summertime. Most other places on the whole planet get their sun and their rain at the same time. So we are in a Mediterranean climate, and California, just like the Mediterranean Sea, part of Europe and North Africa, and then the Southern Hemisphere, Australia, South Africa, and Chile. All 5 of those places have a climate similar to San Diego, and when it is hot and dry is not when we have our rain. We have our drought in our summertime. Most other places don't even need irrigation. In fact, many farms, places where they grow corn and soy throughout the country, they don't even put sprinklers at all. And they may put them out there just to cover if there's a week or 2 of no rain. But here in the Mediterranean climate of California, and especially San Diego, we need irrigation to keep plants thriving in a landscape. So it's important to think about where our water comes from, because no matter where it comes from to get to your irrigation system, it is a precious resource, and we want to make sure it is managed appropriately. So this talk is going to cover, kind of from a big picture on down, where does the water come from and how does it get to the house or the property that we're irrigating. A bunch of learning objectives here. These are kind of standard. The whole point of this talk is to explain the water cycle, the big picture of water supply in California and in San Diego, to talk about how we use water, and a little bit about the laws and regulations, some of the programs, utility-sponsored programs, and the utilities are who sponsors this program, and they definitely want you to know about their programs. So I'll tell you about that too. In the end, we're going to talk about our first piece of the irrigation puzzle, and that is the water meter. We're going to talk about what it is and how to read it, and there'll be a little bit of practice with working on water meters. So for this first part, let's talk about the water cycle and the concept of a watershed. The water cycle is something that you probably learned about in 4th grade, and you probably learned there's, depending on how you look at it, there's 3 main components. Evaporation, so when the water goes up into the sky with the heat of the sun. Condensation is when the water condenses and forms clouds, and eventually it condenses so much that it gets heavy, and then it falls as the 3rd phase, precipitation. Evaporation, condensation, precipitation. And that's the water cycle, and it's what happens all over the planet. And there are many more intricate elements on how this water moves. But basically, the water is taken up from the ocean as well as from plants as they are transpiring water, condenses into clouds, and it'll hit a mountain range, or it will hit a part of the sky that's colder, and the cold air causes it to condense, which then it falls as rain or snow. And then as it falls, it makes its way back to the original source. And typically, in our case, that's the ocean. Along the way from hitting the ground and then going to the ocean, it can be trapped. And that's typically a good thing for us. We want to trap the water for as long as possible. And there's a common phrase that we use called slow it, spread it, and sink it. That's what we're trying to do with our water, with our rainwater when it falls. We want to slow it down, we want to spread it out, and we want to sink it down into the soil. Don't worry about robbing the Pacific Ocean of any water. It's going to get to the ocean eventually. But if we can slow down the path, then we can have more water stored, and it can be stored in the soil. It can be stored in lakes and reservoirs, or it can even be stored in a tank on your house. We want to hang on to that water so we can use it for our landscape and then not need to import irrigated water. So this water cycle must happen. It cannot, you can't stop it, but it is changing, and there are variations that happen over time. It's relatively predictable, but there's good years and there's bad years. There's drought years and there's rainy years. And we want to try to work with nature and be resilient and flexible so that whatever comes our way, we won't run out of water. If we look at how the water is distributed, first of all, over the entire planet, you can see that of all the water on Earth, the total global water, 96.5% is in the oceans, and then another percent is salty water, and we only are left with about 2.5% of fresh water. And so that's the water that's drinkable and available for our plants. Of that fresh water, the 2.5%, the vast majority of that is in glaciers and ice caps, and well over 68%. And then 30% of the fresh water is down in the ground as groundwater, meaning it's been kind of trapped but below the surface, and you need a well to pull that water out. And then of that 2.5% that's actually freely available is only 1.2% of 2.5%. So do you get it? It's a very small amount. That's the surface and other fresh water. So now let's take a look at that surface and other fresh water. 69% of that is found as ground ice. So like when it snows or freezes. And then there's permafrost. So that's up in the Arctic areas. It's not the ice caps, but it's soil that's frozen. And then 20% is found in the world's lakes. And then we get down to the small percentages that are freely available. And that includes the atmosphere, the sky, and the living things themselves, including trees, are full of water, and 0.5% is rivers. So here we see less than 0.3% of fresh water is contained in our lakes and in our rivers. So now we come to this concept of a watershed. And this is a phrase that's being used quite commonly. You've probably heard the term, and if you haven't, that's okay. It's very simple. And the term is defined differently, whether you're in the United States or if you're in another English-speaking country. But in the United States, we define a watershed as the entire catchment of land, the area of land that all drains toward a single point. And that single point can be a water body, such as a lake or the ocean in our case in San Diego, or it could even go inward toward a central valley, which we have on the other side of the mountains. But basically, it's the entire area of land where if rain falls anywhere in that area of land, all the rain is going to flow downhill and flow to the single point. So it's based on our topography, the landscape, and how the earth is shaped. Other countries, they just call the dividing line that goes around up in the mountaintops and the ridges, they call that the watershed, and they call the rest of it the catchment. So it doesn't matter how you really define it. What we're talking about is an area of land that's all connected. It's connected because of its water cycle. So if it rains or snows up in the mountains, that same water is going to come down the hill eventually and be in your area before it leaves into the ocean. So we want to understand watersheds so we can try to manage them as one unit and make sure we're not polluting in one area and causing that pollution to spread, and that we're not stealing too much water in one area and causing another area to not have access to water. So it's important for you to know where your watershed is, and there are many of them in San Diego County. Quick poll, watersheds, select the best answer here. Watersheds A, exist in mountainous areas only. Watersheds B are important to stormwater management. Watersheds C are large areas of land. And watersheds D contain 68% of Earth's fresh water. What do you think? A, B, C, or D? There you go. The answer is B. Watersheds are important to stormwater management. You may say, oh, but aren't they large areas of land? Not always. They can be quite small. In fact, downtown San Diego has a very small watershed called the Pueblo watershed that is entirely urban and has a very small area of catchment. And it flows basically from the hills outside of San Diego downtown and right into downtown, into San Diego Bay. The Pueblo watershed's quite small. In Chula Vista, you're either in the Otay watershed or the Sweetwater watershed. Let's take a look at the water supply in California to understand the big picture. And California is quite an interesting state when it comes to water. It has interesting history, and that history exists to this day. And there's a distribution of water. There's plenty of water in the state. It's just not where all the people are necessarily. So we have to transport it. But primarily in California, we rely on snow melt, and that is the snow that falls in the Sierra Nevada mountain range. And we also rely on rainwater that we store in reservoirs. And then finally, the third piece is groundwater that we pump out of the ground. And primarily our groundwater is pumped in the Central Valley, the San Joaquin Valley, and that's used for agriculture. But all three of these sources are important sources for all of California and all of Californians. So whether you're residential, whether you're agricultural, or whether you are the environment and nature, plants and animals, we all need this water. And sometimes there's a fight over who has the first right to use the water. Now in California, you know that because of its Mediterranean climate, we have all of our rain in the wintertime and it's dry throughout the summer. So our rain year actually starts in October and ends in April. But the water demand is the highest during the summer because that's when there's the greatest evaporation and that's when our plants, for landscaping purposes, need the most water. The other thing that makes California unique is our climate is highly variable. So not only do we have the Mediterranean climate where we have periods of drought every summer, that can vary year by year quite a bit. So take a look at this chart here, which is a map, and the map is showing the fraction of change on the average. So as you go darker in color, you go higher in variation from your average temperature. And this is about a 50-year data set. Notice if you are east of the Mississippi River, there's virtually no change year after year on your amount of precipitation and your temperature. But as you go west of the Mississippi River through the Great Plains, there's a little bit more variation. And then you hit literally the state of California and it's all over the place. And where is there the greatest variation? Southern California, in particular our desert region, but even on the coast. So not only do we have predictable drought, we have the unpredictable drought as well. And then you combine this with the continued population growth, and you can see how management of this water can become tricky. So here's a chart showing the drought severity index for the past 100 years. And you can see we've had good years, which are in green, and we've had bad years, which are in brown. Now, you may look at this and say, okay, well, where's the pattern? And if you look at the most extremes, I see that the second half of the past 100 years have had greater extremes and more on the dry side. Notice how in the first part of the 100 years, we had a lot of green bars next to each other. You don't see that after 1970. You only see one good year at a time or two, and a lot more dry years. Beyond that, the bars are greater. The wet years are wetter and the dry years are drier. And this is consistent with what we can expect as climate continues to change. Now let's take a look at a map of California and try to explain a little bit of how we move water around. So we have a very extensive water system in California, and there's three main components, and San Diego is involved with two of them. So the first component is the Central Valley Project, which is moving water around basically from the Sierra Nevada down to all of the farms in the Central Valley. That goes primarily to agriculture, and we don't see that in Southern California. The next big water project is called State Water Project, and that brings water all the way from Lake Oroville to the Bay Area, and then from the Bay Area down to the San Joaquin Valley, and then down to Southern California. So the blue California Aqueduct dotted line that you see is part of the State Water Project. So that water is coming from Basically, as far as we're concerned, it's coming from the San Joaquin River Valley and the Delta just east of San Francisco. And then Southern California has another source of water, and that's the Colorado River, which is between Arizona and California. So we cut into that at Lake Havasu, and then there's an aqueduct that goes through the desert, up over the mountains, and into Riverside County. And from there, it goes up to Los Angeles and then comes down to San Diego. So the water has to travel a long way. That makes it expensive. It also means that we're not leaving the water where it's supposed to be, and the California and the Colorado River doesn't flow into the Gulf of California anymore unless we allow it to. And the third thing is, as it travels through these aqueducts, it gets evaporated and it's very salty. So we need to try to rely on these as little as possible. And as you may have noticed, San Diego is at the end of the pipe. So if the price goes up or if the supply goes down, who's going to be hurt? San Diego. So there's a big desire in San Diego to have water independence or sustainability using local water resources. Let's take a look at those local water resources to understand the water supply in San Diego County. Here we will show a part of a video. So as you saw in the video, the water in San Diego is managed by the San Diego County Water Authority. And this is their presentation. So we're going to say thank you to San Diego County Water Authority for making Quell available to all of us. And they want you to know they were created in 1944. They serve over 3 million people. And the economy in San Diego County is worth $231 billion. And they provide about 75% of the water that's used across the metropolitan area. And of all of the agencies, 24 of them are members of San Diego County Water Authority. And their member agencies, they are found in 6 different municipal districts or cities in San Diego County. There's 5 water districts, 3 irrigation districts, 8 municipal water districts, public utility, and then we have Camp Pendleton. So there's a lot of players. The water needs to be spread out evenly amongst everybody. So let's take a look at San Diego's climate and situation. This picture with averages above it shows you the amount of rain in inches that we get every single year. So San Diego is known for having 10 inches, and that's based on a 100-year average. You compare that to LA, and LA has 15 inches. You compare it to Sacramento, and that's 18.5 inches. So 10 inches of rain is not very much. In fact, some places will get 10 inches of rain in a single storm. And here, if we get a 1/4 inch of rain in a single storm, we've got floods. So we're only used to 10 inches. Now, that's average. And what were we last year? Last year, we were about 20 inches. And this is on the coast. This is actually at San Diego Airport that they measure this. 20 inches last year. So what that means is if some years are 20, then you know other years are close to 0. And that's been the case for the past 10 years. We've had many of our years 4, 2 inches of rain the whole year. And so sometimes we get double, sometimes we get almost nothing. So we have to be ready to handle living without rain. You can see that in 1946, that was the last year that the regional supply met the regional demand, meaning we have more people that consumes more water than the rainfall allows. And in 2018, That water year, we only got 3.34 inches. That was the second driest in San Diego history. Knowing about watersheds, though, most of our rain goes up into the mountains, and then when it falls as rain primarily, or some snow, it mainly gets trapped up there by the Cuyamaca Mountains, Julian, the lagunas, and then it flows down in our local rivers. So how much rain do the mountains get? Well, they're up around 20, 24 inches per year. So when you look and you say 10 inches, that's all we get. It's not all that San Diego County gets. It's just all that San Diego City gets down at the coast. It's just kind of worth knowing, I think. Let's compare that to San Francisco, 24 inches, and Tucson, Arizona, 12 inches. So you can see a lot of variation. San Diego is more humid than Tucson, Arizona, but still we get about the same amount of rain, but it's totally different. They get their rain in the summertime, which is great for their plants. And Tucson, Arizona actually had pre-Columbian agriculture. So Native Americans in that region it's one of the places where agriculture was developed independently because summertime rain is great for plants. San Diego, not so much. So as far as we review these water sources for California, comes from the State Water Project, the Colorado River. San Diego is at the tail of the pipeline for both of those. And so we're trying to develop our local water sources. And there has been a great advance in the amount of local water that has been captured and even created in San Diego County. And at this point, we are at an average of up to 17% local water supply. It's worth it to mention that water is extremely undervalued. You don't pay what you should pay for the water based on the price of bringing it to you, as well as the cost of going without. We cannot survive without water, so we have to pay it. And it costs a lot to bring it to you. And still, it's relatively cheap. So here you see for a fully treated tap water in San Diego County, you're paying less than 1 cent per gallon, less than a penny. And in fact, it's 0.008. So that's, what would that be? 84% of 1 cent, 0.8 of a penny. And you compare that to a gallon of bottled water, that would be $7.48 for the gallon of bottled water. You compare it to a gallon of milk, $3.68. Compare it to a gallon of gasoline, $3.64. And for fun, you compare it to a gallon of coffee, probably from Starbucks, $22 for a gallon of coffee if you're buying it every day. So 67% of San Diego ratepayers, they recognize that water is a good or excellent value, and it truly is. The fact is, we all should be paying a lot more for our water, and if we did, we could actually afford to implement some more conservation measures because it is such a precious resource, and it's not truly counted for in our costs. Looking at the future, we can expect water resources to become more scarce because the snow in the Sierras will become more erratic. Some years there'll be no snow at all. And then what do? How do we compete with the farmers and with the industry and with all the other households and residences and then still give some to the environment? Because we need to do that too to keep the environment healthy. San Diego being at the tail of the pipe, you can see they're trying to diversify their local water supply. So here in 2020, Here's what the pie looks like. This is all of the local water. Let me verify that. It looks like it's all the water being used in San Diego right now. So there's a couple of things you see here. The main thing to look at is Metropolitan Water District. That's the water we buy from Northern California and from the Colorado River. So you take a look and only 11%. That's a major improvement in recent years. You take a look at our local surface water. So that's our reservoirs in town, the little lakes that we have. 10% of our water comes from that. We've got some groundwater. We've got some seawater desalination. We're taking the ocean and we're removing the salt. It's very expensive and takes a lot of energy. The purple, that's the purple pipe. That's recycled water that's used in the landscape. Little dark purple, potable reuse. That's what they used to call toilet to tap, which is a terrible name, but it's literally taking wastewater and cleaning it up so clean that it's drinkable, potable reuse. And then we've got some other things called transfers. And these are actually like political agreements. So basically it's if San Diego pays to do an improvement somewhere else and that improvement saves water, then San Diego gets that water. So that's what we did with the Imperial Irrigation District and with canal lining. So some of the canals were just dirt and the water was going down into the groundwater. And so San Diego paid to put concrete in those canals, and now the water is not lost. And the deal is, if we pay for that improvement, we get some of that water. And these are ways to get off of the Metropolitan Water District. So what's the plan for the future? The plan for the future is to massively increase the potable reuse. And so notice that purple slice of the pie expands greatly. And if we can do that, we can pretty much get off of Metropolitan's water supply down to 2%. And that will make San Diego much more resilient and able to withstand changes in weather. So this is a good thing in general, but does not solve the problem 100%. We're always going to need to manage water very carefully. So how's water used in San Diego? You can see 65% is used by residential, and then the rest is commercial, agriculture, and public kind of government use. So residential sector is where we have our biggest opportunity to save water. And of the residential, how is it being used? More than half is used in the landscape. And then you've got your toilets and your showers and your faucets and your clothes washing and then your leaks and a few others. And I don't know what other is in this circumstance, but the whole point is we want to reduce our water use in the landscape. And the old school method of just having grass in the front and sprinklers that pop up and you water as much as you want, as much as you can, even though it's cheap enough for you to do it, we don't want to do that because it's a precious water supply that we have. So there are many different programs out there to try to help save water, and they're aimed at the residential level. Now, it's interesting because the government does not have the ability to really regulate your private property. In the United States, we take private property very seriously, and the government cannot tell us what to do on our land. And so we have to try to work with incentives and rebates and making things voluntary. The other thing that can be done is when a house is sold, it can be required that you must make some water conservation improvements to the house as it's being sold. but it's hard to go in and knock on someone's door and say, water police here, you have to fix your leak. And there's actually not really a good mechanism for even the water company to give you a fine if you break that rule or anything like that. So right now it's voluntary. We're trying to teach people to do the right thing, and we're trying to help them plant an appropriate landscape, climate appropriate species, and when you do irrigate, do so in a way that's very efficient and does not waste. That's what we'll be talking about in this class, is how to irrigate efficiently without any waste. So the WaterSmart program, watersmartsd.org, is basically the one-stop shop for the residential customer. Has everything they need to know. There's information, there's videos, there's classes they can take, all the rebates they can apply for. You can get rebates for switching out appliances inside your house. You can get rebates for removing grass and putting in a drought-tolerant landscape. It's all here. So we always direct people to watersmartsd.org. And at Southwestern, our program's very closely linked with WaterSmart. And we have students who are helping to run this program and to teach residential folks about water conservation and their landscape. And if you'd like to know more about how to get involved with WaterSmart, you can send me an email and I will get you plugged in if I can. So one of the things that we want to focus on is landscape transformation. And so primarily involves education and trying to help the customer realize that what they think they want, which is just regular grass or something that they're used to having from the Midwest or the East Coast or England or wherever else they come from, that's not necessarily what a California landscape can look like or should look like. And we have our own sort of style here. It's also not a desert landscape, but it's one that looks appropriate to our climate, and it's going to be very appropriate for your native wildlife, your birds, your pollinators, and it's also going to be quite lovely and pleasant to be in, planting a climate appropriate landscape. Next, let's look at how we use water. And this is just a little bit more general, but helps to clarify what I was just saying. Most of the water use, well, actually 50-50 pretty much, outdoor versus indoor. But the problem is the outdoor water use is more variable. It's harder to tell people to take less showers, shower every other day instead of every day or whatever. It's much easier to address the outside. And as we know, California homes use half their water outdoors. We want to try and reduce that. In California water, the law is kind of crazy. The law says that all water must be reasonable and beneficial in its use. So you legally cannot waste water. But a beneficial use of water is irrigation. So if you're irrigating anything, that's a beneficial use of that water. And reasonable use changes based on different years. So some years in drought, it's not reasonable to use the water 100%. They want you to cut back. It's important to know in California law that the water user does not own any water. The water rights are the legal entitlement to divert the water from a specified source. So this goes back well over 100 years to something we call water rights. And in California, it's kind of interesting because it's first come, first serve. Whoever claimed it first gets to have it. And they can even sell their water rights to someone else. So a lot of our water is bought and sold by the institutions and the families that were here and originally claimed it as their own. And in order to claim it, you had to take it away from the environment. You had to divert it from its natural course. If you've ever seen the movie Chinatown, the classic movie, the water diversion plays a key role in that movie. So we've got a dual system of water rights. The first is riparian rights. And so that means if you own a piece of land and it's adjacent to a source of water and it passes through your land, you have some right to it. Although you want to watch out because you may or may not own the riparian area. And then we've got appropriative rights. And that is where the water can be diverted to used at a different location. Riparian rights have priority over appropriative rights, and appropriative rights have priority according to date, meaning first come, first serve. Whoever had it first, whoever claimed it first, has the appropriative right to the water. In California, the water is regulated by the Environmental Protection Agency. And in our state, we've got our own Cal EPA. It's the California Environmental Protection Agency, usually stricter than the federal government. And they're responsible for developing and implementing the environmental laws that regulate our air, water, and soil quality, including pesticide use and waste water recycling and water reduction. So that's where all of the state agencies come from, is underneath the California EPA. And that's kind of the primary regulatory body. And then other key water resources and agencies is the California Department of Water Resources, DWR. They manage the State Water Project. And then we've got the California Energy Commission, and they have to do with developing irrigation efficiency standards, because energy and water are closely linked. So energy is primarily used, believe it or not, in moving water around. So to move all this water, the State Water Project, it takes a ton of our electricity. On the flip side, in order to produce electricity, it takes a lot of water. It either takes ocean water or fresh water, but you need to cool down these power plants. And so it takes a lot of water to make the electricity, and it takes a lot of electricity to move the water. And that's called the water energy nexus. The idea that if you can conserve water, you're also going to be conserving electricity. So starting in 2014, we saw the worst drought in recorded history in California. It officially went until 2017, but we've kind of hopped back and forth since then into drought and out of drought. And that was the worst drought in at least 500 years, according to the tree rings that we can count on very old trees. But no one really knows how long it's been since it was that dry. But we do know we can expect droughts to be more frequent in the future. And so therefore, these agencies, they came up with what's called the framework to make water conservation a way of life in California. So the goals of the framework are to use water more wisely, to eliminate water waste, to strengthen drought resilience, and to improve agricultural water use so that we can manage droughts. And this framework is going to be the kind of the goals that base all future legislation and laws. So as new laws come out, they're going to be measured against those four main objectives. And one of the ones that matters for landscapes, and especially, horticultural, commercial, residential landscapes, is what we call MWELO. Some people say MWELO. MWELO. I think that's kind of hard to say one way or another. What it stands for is the Model Water Efficient Landscape Ordinance. So basically, California created a model. They said, all of our cities, you better implement something like this. And it's a formula. It's a way for irrigation in the landscape to be counted and made sure no waste takes place. It's very technical. A lot of people don't know how to do it. You can get a lot of money if you understand how to do it. I'm going to teach you how to do it this semester. So the ordinance requires that new construction and certain rehabilitated landscapes, they need to meet what's called a water budget. And so the ordinance is updated every 3 years, and it's in line with the building codes for California, which we call Cal Green. Title 24, which is the green building standards for California. In order to build a new house or to build a new anything, you need to get permits. In order to get the permit, you have to meet the water budget. And so I'll show you how to do that in this semester. And then we've got our local utility sponsored programs, and we'll show you what those are. So here we've got our SD Water Smart, San Diego County Water Smart. And then they've got SoCal Water Smart, and don't get them confused, but they're kind of two of the same thing. We've got our countywide programs, Water Smart Landscape Makeover Series. That's what our school's very closely involved in. We've got the California Friendly Landscape Training. We've got Water Smart Checkups. We've got the Qualified Water Efficient Landscaper Training. That's what is within our class here. That's what you're participating in right now. And then there's rebates. For residential, there's the Water Smart Checkups. You can get rebates on turf, weather-based irrigation controller, high efficiency irrigation components, soil moisture sensors, rainwater harvesting rebates, gray water, toilet, and clothes washer rebates. If you're going to buy something new, you get a rebate if you buy a water efficient one. And then there's information, classes, videos, guides, and they'll give you a weekly watering schedule, which be careful about using, but it's a great place to start. And then for commercial, they've got pretty much the same rebates, but they'll also give rebates on like kitchen, industrial kitchen equipment, food equipment, and commercial restroom fixtures. And then they'll help with getting you to use purple pipe in your irrigation. So you're using reclaimed water for your landscape. You don't want to use that if you're residential, but for commercial landscapes, that's the way to go. And then they will train people to have a professional certification that's nationally recognized, QUEL. That's what you will have when you pass this class. And you can do water audits, and you can become much more employable. Okay, so now the last piece, we're going to take a look at water meters, and then you'll have some sample problems. This is the first component that we're going to look at with our irrigation system at home. The goal here is to be able to read the meter, to understand how it's used, and to perform a basic leak detection. So what is the water meter? The water meter is a device that measures the volume of water that's used at a home or a business. And it's usually installed, owned, and maintained by the water supplier. So meaning you don't mess with it. In fact, it's illegal if you do. If you go and tamper with the water meter, or if you shut it off on the wrong side, that's a problem. And it varies based on the utility. There's different styles out there. There's digital, there's the old school. And basically, as water passes through a pipe, it spins a little thing, and that counts the amount of water that has passed through. So it's calibrated, and the more it spins, the more the ticker counts. And every month they come and check, they see how much you've used, and they charge you for the difference, how much you used that month. So in California, the law requires that any home built after 92 has a water meter, and that any home built before 92 needs to be retrofitted by 2025. Believe it or not, there are many homes in California that don't have a water meter at all, meaning they don't pay for water, at least not on a usage amount. In San Diego, pretty much you've always got a meter unless you're kind of in the agricultural part of the county. But here, we're trying to make an effort in California to get everyone to have a water meter so that everybody pays their fair share. And here, the ordinance for water efficient landscapes now requires that you have a separate meter for your irrigation system. So you have a main meter coming into the house, and then when it branches off to the irrigation, another meter there. And that's required for any landscape, residential, that's larger than 5,000 square feet, or any non-residential landscape that's larger than 1,000 square feet. And some local cities may have more strict regulations than that. Now, why would you need a separate meter for your landscape? Perhaps it is because in the future, when everybody has a landscape meter and a regular meter, you will be paying a different rate. You'll be paying potentially more money for irrigation water than you will for sink water, shower water, and to wash your clothes. So they're putting the pieces in play to be able to charge you more for irrigation because they want to really reduce the amount, and they can't tell you what to do, but they can make it more expensive. That's the way to get around some of the legal requirements. So it's worth it to get ahead of the curve and to start conserving water now. Here we see basically just categorize the meters. Right now, everyone pretty much has what's called the mixed use meter. That's for both indoors and outdoors. You can have a dedicated irrigation meter, which measures only outdoor water use. We do have those at parks and HOA areas and sports fields, not at residential yet. And then there's a sub-meter. So you can choose, if you want, to take better management, and you can install your own meter to keep track of water. But that's kind of after the main meter. The water district won't read that one. That's for your use only. And they consider those to be called sub-meters. So you use a meter to understand how much water is being used over a specified time period. And if you're only turning on one sink or flushing one toilet, you can check to see how much each of these different things are using in a property. And for the landscape, you can turn on one set of sprinklers and then run it for 10 minutes. And then you can do a little math and you'll figure out how many gallons that water actually uses. It's a way to manage water use over time. And we can also use it to check for leaks. So if we think everything should be off, but something is spinning, that tells you, hey, there's a leak somewhere. And finally, the utility will use it to give you your bill, to charge you for your water use. Now, most of the water districts, they have switched over to using the units of 100 cubic feet. There's still a few districts that use the old method of 1,000 gallons. So basically, you pay for every 100 cubic feet. Cubic feet's kind of a hard thing to visualize, but imagine 12 inches, 12 inches, 12 inches. That's a volume of water. They charge you for every 100 of those that you use. So the water meter will measure in either gallons or cubic feet. 1 cubic foot equals 7.48 gallons. That is a conversion factor that you will use in a couple calculations in a few weeks. But I'll always give you that. You don't have to memorize it, but it's good to recognize it. 1 cubic foot equals 7.48, 7.5 gallons. 100 cubic feet, therefore, equals 748 gallons. And so you get charged for every 100 cubic feet. The meter measures every 1 cubic foot. So notice in the image there, the last 2 digits are black background. So that's the 1 and the tens place. And then the one in the white background, that starts with the 100 cubic feet. So you don't pay anything until you tick over to 100. If you go up to 150, you still pay for 100. Once you go to 250, you pay for 200. And each 100 is 748 gallons. There's the arrows just kind of pointing that out. Now, there's different types of meters. We've got straight reading meters. They're very common, and it's your typical residential meter. And basically, you have a large red dial that spins in a circle clockwise. And typically, one sweep around the face is equal to 1 cubic foot. So you can see there it's demarcated in decimals. So 0.1, 0.2, 0.3. You go around in a full circle, that's 1 cubic foot. You go around 100 times, you get charged for 100 cubic feet. And then there's that little triangle. You see the red triangle there on the side? That's the low flow indicator. And if there's just a tiny little trickle of water coming through, that will be spinning. That's how you can detect your leaks. So if there's a lot of water coming through, that thing spins very fast. But if there's only a little bit of water, the low flow indicator will be your guide to tell you that, hey, something is moving through this pipe. More and more common are becoming digital reading meters. And those are nice for a few reasons. First of all, they're easier to read because it's just a regular number. The downside is they require some power in order to operate. And the upside for the utility is they don't need to come and pull open the cover and look. They can actually just come on up and with Bluetooth pretty much, they can do a reading to look at your meter. So they don't have to get out of the truck. They can just drive by and your meter tells the operator how much water you've used. So digital data is nice because it's there's less errors and easier to manage if everyone has access to the data. So let's take a look at a sample water bill from the San Dieguito Water District. This bill happens twice a month, so every 2 weeks. And you can see it is billing in 100 cubic feet. So down there in the red circle, you can see 1 unit equals 748 gallons. And so in addition to water usage, the customer is paying for a basic service fee, $42. No matter how much you conserve, you're always going to pay that. And then notice there's a tiered rate. So for your first 12 units, you pay $2.99 per unit. Then for your next 8 units, you pay $4.75. And then up into tier 3, you pay an even greater amount. So the more water you use, the more you pay for that extra water. And that's typically how these water bills are structured. So you can see here that the usage is based on adding up of all of your tiers, the amount of units, the amount of 100 cubic feet, and in this case, it's 22. So here's a quick review, Q&A. There's a commercial property with a mixed water meter. It receives a bill for 50 units of water, and the meter measures in cubic feet. How many cubic feet of water were used? For reference, remember that water charges are based on 100 cubic feet, referred to as the billion units. And that would be 748 gallons. So as a bonus, you could tell me how many gallons of water were used. Let's take a look. So if we had 50 billion units of water and 1 unit is 100 cubic feet, then we do 50 times 100 and we get 5,000 cubic feet. That's how much water was used. How about that bonus question? We would take our 5,000 cubic feet of water, multiply it by 7.48, because that's how many gallons are in 1 cubic foot. We end up with 37,400 gallons. It's a lot of water. So here's the step-by-step method on how to read a meter. You locate the water meter, you remove the lid, visually examine the area for harmful insects, other animals. You don't want to get a black widow bite by sticking your hand in there. You want to read the numbers on the face, or you can take a photo with your phone. That's much better. You here in this image, the meter is showing 3,699,380 gallons. Notice it's gallons. So that's how many thousand gallons. That's what this meter is measuring. That would be 3,699,000 gallons. So we would subtract the previous reading to determine the water usage. And let's just say the previous reading was 3,673,000 gallons. So if that's the case, what would the usage be? 3699 minus 3673, we have 26. 26 what? 26,000 gallons. Now you want to ensure that no water's being leaked. And so make sure you turn off everything. You don't expect anything to be running. And now you take a look and check out that low flow meter and see for yourself, is anything moving on the flow meter? And if it is, you can try to determine the size of the the size of the leak. So what you would do is take a look at where the meter is and then come back in 10 minutes and put a stopwatch on, and you can measure how much was lost in 10 minutes. And then you can find out how many gallons per minute is leaking. And that tells you the amount of water that you need to fix. And if in your landscape you have different shutoff valves, you can go and turn them off one by one. We call those isolation valves because that will help you to see if, oh, you turn one of them off, now the leak detector stopped spinning. You can kind of start to figure out where your leak is located in the landscape. So quick review, Q&A. A residential property has a water leak. The property has a mixed-use water meter. When the water was turned off at the entry point to the house, the water meter stopped. Where is the leak? Is it indoors? Is it outdoors? Is it indoors and outdoors? Or is there not enough information provided? The leak is indoors because if you turn off water to the house and the leak detector stops spinning, that tells you your water usage has stopped. And since you cut off the house and the leak stopped, the leak has to be in the house. Water meter maintenance is not anything you really have to worry about. It's the responsibility of the water supplier, so you don't need to mess with it. In fact, if you do mess with it, you can get in trouble because you can break it and cause a big problem. If you need it to be shut off, you have to call the water provider and get permission to either shut it off yourself or they will come up and shut it off. So don't go and turn off the water meter. The person who owns the property and pays the bill, they're going to be responsible for any costs of repair to the water meter if it's something that is your fault if you mess with it. And so if you see a problem, you need to contact the water supplier and they'll come out and fix it if there's a weird noise or if the meter doesn't seem like it's reading correctly or if there's some problem. And you need to know who to call. You call whoever you pay your bill to. So to wrap it all up, here's the quick review. And when I say quick, I mean quick. After this, you should be able to 1, explain the concept of the water cycle. 2, explain what is a watershed. 3, how can a residential lot be viewed as a small watershed? Interesting question. True or false? California's climate is highly variable and is prone to cyclical periods of drought. True or false? California has built a water system to move water around the state. Where does San Diego County's imported water come from? Name the 2 types of local water sources in San Diego County. True or false? San Diego County Water Authority is a retail water agency. Name 4 sources of water utilized by retail water agencies. True or false? The majority of water supplied by San Diego County Water Authority is surface water. 10 more questions for you. What are the primary uses of water in the average household? Name the 2 California state agencies responsible for regulation and management of California's water supply. True or false? The MWELO and Cal Green are regulations that ensure that new homes and landscapes are water efficient. True or false? EPA, WaterSense, Save Our Water, and LEAD are national or statewide water efficiency programs. Who should you check with for information about local water use efficiency programs? What is a water meter? What are some reasons to read a water meter? What are the 2 units of measurement used by different water meters? What are the 2 billing units used by retail water agencies? And what's the easiest way to check for a leak? So there we go. That's our introduction. It's kind of dry, in my opinion. It's not the way I would have created a presentation, but the information's pretty good, and it's important that we hear it from the source and that we start to understand all about where the water comes from and why efficient irrigation is so important. These questions will come up. We'll have a chance to practice them. All the answers will be found in the manual that you receive, and we can find it online as well. So I hope you enjoyed this conversation. Let's hear from you in the discussion, and let's see how you do on these little practice problems. Thanks a lot.